Hi, welcome to SproutPod. Today let's carry on with another type of firewall. Stateful Firewall, also known as Dynamic Packet Filtering. Stateful Firewall keep track of the state of connections, meaning it will check whether a packet is part of the response to a request. Individually crafted packet will not be able to pass through the firewall, as the firewall will check the state table before the filter rules. As such, the stateful firewall is also known as connection-aware or state-aware. Example: if an internal desktop is trying to go to external site google.com, the first packet will hit the firewall. The firewall, seeing this as the first TCP SYN packet, the firewall will create an entry in its state table, check with the firewall permission, and let the packet through. If the firewall rules allow, when google.com reply with a SYN-ACK packet, it does a check with the state table. If this entry is in the state table, it will allow the packet to pass. So, if a hacker randomly crafts a packet to hope to get through the firewall, without the right state table entry, it will get dropped or rejected. Stateful filtering also check on the source and destination IP address and port. It does additional check on the session bits of TCP protocol. For stateless protocol, like UDP, it will create a state table to keep track of the sessions. Whether it works on the session layer has been a topic of debate, but for simplicity's sake, we will consider it working on the session layer as it maintains a session table for stateless protocol. An example of the state table is as follows. The firewall creates the session entry for stateless protocols like UDP and ICMP. For UDP it uses the source IP, source port, destination IP, and destination port for entry record. Handling ICMP requires some more fields as it has no ports. Some implementation will use the protocol, the ICMP type, and code. Note that some vendors do not support all the types and codes of ICMP. For stateful firewall, some of the well-known attacks are SYN flood. As every SYN packet is sent, the firewall puts an entry into the state table, usually in the memory. Firewall memory is a finite resource. When the state table is full, the firewall will drop new connections, even legitimate connections, creating a denial of service on its own network. This is an old attack, which most firewall vendors have solved, by timing out entries that do not complete the connection. However, the important concept to understand is how attackers play with finite resources in the defense mechanism. Another important concept is, stateful packet filtering is not the same across all vendors. Every vendor has a slightly different way to handle stateless protocol. You need to take note, and ensure the firewall's capability. Stateful firewall offer better security than static packet filtering in the way that most crafted single packet attack won't pass through easily. It is also quite fast as compared to the proxy firewalls. It is definitely slower than a static packet filter, as it needs to check more packet contents in the state table. However, given the processing speed today, a lot of stateful packet firewall can go up to gigabits of throughput. Some of the disadvantages are, the stateful firewall is still not application layer aware. We like to use FTP as an example, because FTP has a command connection and a data connection. Also, not all stateful firewalls are built the same. It is dependent on the vendor. Finally, it is also more complex to administer, requiring the firewall administrator to understand more network protocol knowledge. In summary, stateful firewall should be used for a decent perimeter defense. Stateless protocols are the challenge. It is more complex to be administered. Be sure to research properly with the firewall vendors on the details. You need to understand what are the possible attacks that might come through the firewall.